Despite huge successes, the global control and banning of industrial chemicals that destroy the Earth's protective ozone layer has resulted in a large-scale illegal black market that threatens our environment. Chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons, HCFCs, are inert, odourless, and invisible chemicals. That's exactly why they work so well in refrigerators, air conditioners, or as aerosol propellants. Cheap to make, CFCs were thought to be harmless until a chance discovery that they destroy the Earth's protective shield, the stratospheric ozone layer. CFC refrigerants like R12 destroy stratospheric ozone. So too do halon firefighting agents and the pesticide methyl bromide. In the mid-1990s, an estimated 15% of the world trade in CFCs and halons was illegal. Smuggling these ozone-depleting substances was big business, on a par with the drug trade.
The reason for ODS smuggling is profit, it's money. What we're seeing is illegal trade growing in developing countries, and the reason for this is that there's a lot of equipment still out there which uses CFCs, and although the alternatives are available, they're more expensive. So by providing CFCs at a cheaper price, their use continues. Hence the smugglers bring them in, making money for themselves.
Today the trade is reduced because of awareness, trained customs agents and vigilance, but illegal shipments still happen. As further substances are banned, smuggling could go on for some time, which threatens the recovery of the ozone layer. Why does smuggling of ozone-depleting substances, ODS, happen? What's been done to stop the smuggling? And how can the illegal trade be further prevented so that the ozone layer can recover? The ozone hole continues to be a significant problem at both ends of the globe and in between. Millions are now regularly exposed to dangerous radiation, unprotected because of missing ozone. The discovery of the ozone hole 30 years ago led to concerted research into the causes, the identification of man-made chemicals that are responsible, and to the international treaty known as the Montreal Protocol.
The Montreal Protocol on substances that deplete the ozone layer has now been ratified by nearly 184 countries all over the world, which means that about 99% of the humanity and more than 99% of production and consumption of ozone-depleting substances are now part of this global environmental treaty.
The protocol identifies a list of specific chlorinated, fluorinated or brominated hydrocarbons used for refrigeration, as foam-blowing agents, solvents, as fuel, and for firefighting as ODS. Countries that joined the protocol agree to phase out the consumption and production of ODS according to a strict timetable. The phase-out varies according to the specific chemical, with the most harmful group largely phased out in 1996 in developed countries and in 2010 in developing, or so-called Article 5 countries. A multilateral fund provides financial and technical assistance to developing countries to enable them to comply with the treaty. This includes training of customs officers. Consumption of ODS is reduced stepwise before the total phase-out. There are exceptions for essential uses. Apart from agreements with industry setting out the restrictions on substances and technologies, the protocol sets out regulations for licensing and labelling.
If it is a gas such as R12, which is a CFC, same as R11 and 502, we have to apply to the European Commission for an EAN BDN number. On the application you have to put in the port of exit, the producer of the gas, and then they will issue you with a number within a day or two. As long as the country that it's going to is an Article 5 country, which it must be for a CFC, then they will issue you with a licence. We have to issue a dangerous goods note. This note accompanies the container on the vessel. It's given to the captain of the vessel. On there, you have to list everything that's in the container, and you have to give a description of the hazard, what the gas is, the class number, the UN number, etc. The container arrives, it's loaded, and a delivery note is then issued. That is given to the driver to get together with a transport emergency card. Once the vessel has sailed, they then issue us with a bill of lading. And this is proof then of export to the Customs and Excise, if they come in to audit us, as to exactly where the container went, to which country, what was in the container. And that is what is known then as proof of export.
As most developing countries do not produce ODS, they have to import them. Many countries now regulate import-exports of ODS through licensing and permit quota systems. These licensing systems are mandatory for all countries that have ratified certain amendments to the protocol and apply to virgin as well as recovered, recycled or reclaimed ODS. These licensing systems also include quotas that restrict the import of ODS and that become more restrictive each year until complete phase-out prior to 2010. A national ozone unit is responsible for coordinating ozone protection-related activities in the country. The system requires action by importers, issuing authorities, government agencies and customs officers. Although they do not count as imports or exports, transshipments also need monitoring to prevent contraventions of the protocol. The country should then introduce provisions for penalties, handling and destruction of ODS, including safety precautions necessary when sampling ODS, especially in confined spaces.